Hey everyone and welcome to the CBSE session on circles. In this session, we are going to discuss previous year questions based on circles. So without any delay, let's begin. So in circles, let us try to understand how many questions were previously asked from 2022-24. If you see, 1 mark question is very important from this particular chapter. You can expect at least one question of 1 mark from this chapter. Also, if you see from circles chapter, 4 marker and 3 markers are also very important because they're continuously asked in 2022, 23 and 24. You can expect a long question, 3 or 4 marks from this particular chapter. So if you see the overall weightage, it is around 6 to 8 marks. So you can expect 2 to 3 questions. One is 1 marker, one is 3 marker, one is 4 marker. Tentatively, that is what you can expect from this chapter, which is very important. So let's begin with the questions now, and before that you can also have a look at this. So many variety and range of questions are previously asked, like if you see in 2023 and 2024 as well, 4 marker, 3 marker, 1 marker. So almost all the varieties you will find in this particular chapter. Okay, so here is the first question. It says, in the figure, triangle ABC is circumscribing a circle. Triangle ABC is circumscribing a circle, then the length of BC is how much? Okay, so the figure is given. You can see triangle is circumscribing. That means it is outside the circle and the circle is touching the triangle at its 3 sides. We are supposed to find out the length of BC. Now this is very simple. No need to write down ample of steps here because it is just a 1 marker. So if I see point A, from point A, can I say AP and AR will be equal? Because we know that the length of the tangent segments drawn from an external point are equal. So I can say AP is equal to AR. So how much will be AR? AR will be 4, isn't it? Now tell me one thing, if AR is 4 and entire AC is 11, how much will be RC? Can I say this RC or CR will be 11 minus 4? So can I say RC or I can say CR will be 7? Understand the question. Now if CR is 7, can I say the CR is equal to CQ because from point C there are 2 tangents drawn. So can I say CQ will be 7? I hope you are getting this. Now from point B there are 2 tangents drawn, BP and BQ. So can I say if BP is 3, BQ is also 3? I hope you are getting this. So you can just write that down. That is CR is equal to CQ. CR is equal to CQ. That is going to be 7. And then BP is going to be equal to BQ. And that is going to be 3. All this is in units, right? And the reason for all of this is what? The length of the tangent segments drawn from an external point are equal. So can I say the entire BC is going to be equal to BQ plus QC, and that is equal to 3 plus 7, and that is equal to 10. So 10 is the answer. So this is a fill in the blanks. The length of BC is 10 centimeter. Okay, everything is in centimeters, so obviously here also you can write down centimeter. See, I have given you the entire explanation, but if you are able to do it quickly on your own, you can easily do it. This is 4, this is 4, 11 minus 4 is 7, this becomes 7, this is 3, this is 3, 3 plus 7 is 10. Correct? Okay, let's continue. So 2 mark question asked in CBSE 2020. So in the figure, 2 tangents TP and TQ are drawn. So TP and TQ are 2 tangents and O is the center of the circle. We are supposed to prove that angle PTQ, this angle is a double of angle OPQ. Okay, so angle PTQ is double of angle OPQ. Alright, so now let us try to understand this. If I take TP and TQ, can I say both of them are the tangents drawn from the external point? So can I say TP is equal to TQ. TP is equal to TQ. What is the reason that you will write down? Write down the entire reason. Length of the tangent segments drawn from the external point are equal. So can I say angle TPQ is equal to angle TQP. Angle TPQ, this angle, will be equal to angle TQP, because if I have an isosceles triangle, the base angles are going to be equal. I'm taking this as x and x. Both of them are equal, isn't it? I'm taking that as x and x. Correct? Now, what we will do is, I'm taking this angle OPQ, the inner angle OPQ, as y. So I'm assuming, let angle OPQ be equal to y. This is just for your understanding. If you don't want to take x and y, you don't take it, that's okay. But that makes it a bit simpler, how I'll tell you. Now understand. In triangle PTQ, what is sum of all angles of triangle? In triangle PTQ or PQT, can I say x plus PTQ, PTQ plus x is equal to 180 degrees. X plus PTQ is 180, because sum of all angles of the triangle is 180. So can I say PTQ plus 2x is equal to 180. So can I say PTQ is equal to 180 minus 2x. If I take 2 common, can I say PTQ 2 common 90 minus x. Correct? PTQ is equal to 2 common 90 minus x. Now understand. This is interesting. Now tell me one thing. Can I say OP is perpendicular to PT? This angle is 90 degree. Because radius is perpendicular to tangent, we already know. Radius and tangent are perpendicular to each other. OP is perpendicular to TP. So can I say angle OPT is equal to 90 degrees? This entire angle OPT. But if you see very carefully, what we have done is, this entire angle is broken into two parts. This part is x and this part is y. See, we have taken y, no? So can I say x plus y here? Can I say x plus y is equal to 90? So from here, can I say that y is equal to 90 minus x? Y is 90 minus x. Now put this 90 minus x as y there. So can I say this becomes angle PTQ is equal to 2y. But what is y? Y is OPQ. Have we proved this? Yes, we have proved it. 2 times angle OPQ. Correct? This is how we prove it. Easy. If you don't want to take x and y, you can use the angles, but that becomes very lengthy, you know, O, P, Q, P, T, Q. Rather than that, you take x and y, you can take A and B. That's your choice. Perfect. Let's continue further. Now the next question says, PQ is a tangent to a circle with center O. This is again one marker. We are not going to waste a lot of time on this. So PQ is tangent to the circle with center O. So there is a circle and there is tangent PQ at point P. So P is on the circle and there is O. What they are trying to say is, they are trying to say this is an isosceles triangle, right? It's already given that triangle OPQ Triangle OPQ is isosceles. Now since triangle OPQ is isosceles triangle, this angle, can I say angle OPQ firstly is 90 degrees. Why? Because tangent, write down the reason, tangent perpendicular to radius. Write down the complete reason actually. Tangent is perpendicular to the radius at the point of contact. That is the reason. This is 90. Since it is an isosceles triangle, can I say OP is equal to OQ? So OP is equal to OQ is already given. So can I say these two angles will be equal now? So OQP is what we are supposed to find out. So if I take this as x and if I also take this as x, obviously both of them are equal because this is an isosceles triangle. The base angles are equal. So can I say x plus 90 is equal to 180? So can I say 2x is equal to 180 minus 90, that is 90. So x will be equal to 45 degrees. Very simple question, isn't it? So x is 45. That means OQP, this angle, is 45 degrees. The other angle is also 45 degrees. Both of them are 45. Easy? Very easy. Perfect. Let's continue. Okay. The next question says, two concentric circles. What is the meaning of concentric circles? Concentric circles means two or more circles having same center but different radius. So, okay, see, different radius. The radii are 10 and 6. Find the length of the chord of the larger circle which touches the smaller circle. Okay, let's try to analyze first by drawing two concentric circles. So, this is the first circle. This is the second circle. Here is the center. Correct? The length of the chord of the larger circle. So, larger circle has a chord. Larger circle has a chord. Okay, let us draw a chord. So, let that chord be chord AB. Now, the length of the chord of the larger circle, we are supposed to find out. Okay. The question says, the radii are 10 centimeter and 6 centimeter. So, if O is the center of the circle, I say this OA is a larger radius, which is 10 centimeter. I say, if I take a point C over here, this is the smaller radius. So, OC is the smaller radius, which is nothing but 6, isn't it? Okay. So, we can analyze something here, right? So, initially you will write down there are two circles with center O and all that. What is there? We can write down OA is equal to 10 centimeter. Okay, this is given. Then OC is equal to 6 centimeter given. Now, can I say OC is perpendicular to AB? Understand? OC is perpendicular to AB because what is OC? OC is the radius. What is AB? AB is the tangent to the smaller circle, isn't it? So, we know that radius is perpendicular to tangent. That means this angle is going to be 90 degrees. So, angle ACO, that is angle ACO is equal to 90 degrees. Now, we know that we can apply Pythagoras theorem. So, we can say by Pythagoras theorem, write down the complete statement by Pythagoras theorem, right? We'll say OA square is equal to OC square plus AC square. So, OA square is 10 square is equal to OC square, that is 6 square plus AC square. 10 square is 100. So, 100 is equal to 36 plus AC square. Now, you know how to solve this, right? So, AC square is 64. AC square is 64. So, AC is square root of 64. So, AC will be equal to 8. 8 what? Centimeter. So, AC is 8 centimeter, right? that perpendicular drawn from the center of the circle to the chord of the larger circle bisects the chord. So can I say AC is equal to BC? What is the reason you will write down? Again you will write down the complete reason. The complete reason says that for bigger circle with center O, perpendicular drawn from the center of the circle to the chord bisects the chord. So AC is equal to BC. So can I say BC will also be equal to 8 centimeter? So here tell me what will be entire AB. AB will be 8 plus 8, that is equal to 16 centimeter. Yeah, 16 centimeter is the final answer. Easy, simple. So that's it. This is how you can prove it. I hope you have understood this question. Let's continue further. It was asked only for 1 mark, but that's how it is. Can't really help. So the next question again is for 1 mark. Okay, the figure is not given. We have to actually draw the figure. It says if tangents PA and PB from an external point P to a circle. External point P to a circle. There is a circle. There is a circle. Tangents PA and PB. Two tangents from P. So PA and PB. Two tangents to a circle are inclined at 70 degrees. Okay. So this is 70 degrees. Now the question says find POA. So this is O and this is A. And the question says we are supposed to find out this angle POA. Now see, this is very simple. Firstly, if I consider the two triangles, triangle POA and triangle POB. Can I prove the two triangles congruent? See, it is very easy. Can I say PA is equal to PB? Yes, I can say that. I can say PA is equal to PB. Correct? Then, if PA is equal to PB, can I say OA is equal to OB? Yes. What is the reason for the first one? Reason for the first one, you have to write it down. Length of the tangent segments drawn from an external point are equal. What is the reason for the second one? They both are the radius, right? OA is the radius, OB is the radius, so obviously they'll be equal to each other. And the third one is OP, which is the common side. OP is equal to OP. So can I say the two triangles are congruent? Triangle POA congruent to triangle POB by side test, right? So if these two triangles are congruent, this angle and this angle will be equal, correct? So can I say angle APO will be equal to half of the entire angle 70. Obviously, that is 35 degrees. So this inner angle, the blue one, is 35. Can I say angle A is 90 degrees? Angle A is 90 degrees. What is the reason? The reason is tangent is perpendicular to radius. Now comes this angle. Now can you find out this angle? The sum of these three angles is 180. So angle AOP or POA, angle POA plus 90 plus 35 is 180. So 90 plus 35 is 125. So can we say angle POA plus 125 is 180. So if I shift 125 to the other side, I get angle POA is equal to 55 degrees. Correct? So yes, 55 degrees is the answer. Even if they ask you this angle, that is also going to be 55 degrees. Correct? Because the triangles are congruent anyways. Okay, Let's have a look at a new question. It's a 3 marker now, so it can be a bit lengthy. So this is the figure given. Let's try to analyze the figure. So obviously ABC is a right angle triangle, and triangle is circumscribing a circle. That is, triangle is outside the circle with BC as 6 centimeter. Okay, so this entire BC is 6 centimeter. Okay, AB is 8 centimeter. So this AB we are supposed to find out the value of R, where R is the radius of the circle, rest all is normal already given. So R means what? If I join OQ, that can be R, right? Or if I join OP, that can also be called as R. So we are supposed to find out the radius of the circle. Okay. Before finding out the radius of the circle, can we say here, understand very carefully, this is 6, this is 8. Can we find out AC? Angle B is 90 degrees. Angle B is how much? 90 degrees. So can I say AC square is equal to AB square plus BC square. So can I say AC square is AB square, which is 8 square plus 6 square. So can I say AC square? Okay, I'm doing it directly now. 8 square is 64, 6 square is 36, 64 plus 36 is 100, right? And the square root of 100 is 10. This you know. So AC is 10 centimeter. AC is what? AC is 10 centimeter. This is 10 centimeter. Now understand. Now can I say OQ is the radius, OP is the radius, correct? This we know. Then we also know that OP is the radius, AB is the tangent, this is 90 degrees. OQ is the radius, BC is the tangent, this is 90 degrees. So firstly we will write down angle P is 90, angle Q is 90, because tangent is perpendicular to radius. This is the entire reason. Then angle B is also 90. See? Given, no? This is given. So can I say the remaining angle? That is also 90. So the remaining angle POQ, that is also 90. So once all the 4 angles are 90, can I call it as a rectangle? If all the 4 angles are 90 degrees, it is a rectangle. But if you see, in rectangle opposite are equal, right? But here adjacent are also equal. OP and OQ are also equal. Always remember, this tells us that it is a rectangle, and this tells us that adjacent sides of rectangle are equal. And whenever adjacent sides of rectangle are equal, it is a square. Basically, it is a square. So this is also R and this is also R. What did we understand from the figure? We understood that this particular figure entirely, this is a square. This is R, this is R, this is R, this is R. So now, tell me one thing. If I want to find out QC, can I say QC will be 6 minus R? Entire is 6, this is R, so QC will be 6 minus R. Can I say CQ is equal to CR? CQ is equal to CR. So CR will be also equal to 6 minus R, because we know that the length of the tangent segments from the external point are equal, correct? Now this is R, entire is 8, how much will be the remaining part AP? Similarly, can I say AP will be equal to entire 8 minus R? So if AP is 8 minus R, Can I say this AR is also 8 minus R? So this is 6 minus R, this is 8 minus R. Now understand. So we got this as 6 minus R and we got this as 8 minus R. This entire part is 10. This entire part is 10. So now can I say that AR plus RC is equal to AC? So 8 minus R plus 6 minus R is equal to 10. So 14 minus 2R is equal to 10. So 2R is equal to 4. So R will be equal to 4 by 2, that is 2. So can I say that the radius of the circle is nothing but 2 centimeters? And we have got the final answer. The radius is 2 centimeters. I hope you have understood this question. Slightly complicated, I know, but at the same time easy as well, isn't it? Okay, let's continue further. The new question says, in the given figure, PT and PS are tangents to the circle. You can clearly see PT is a tangent, PS is a tangent. Center is O, PT is 4. Okay, PT is 4 centimeter. And then it is given that angle TPS is 60 degrees. Then find the length of the chord TS. We are supposed to find out the length of the chord TS and then also find out the radius of the circle. So radius is nothing but TO, right? Radius is TO. Now this is a simple question. Now understand, can I say triangle PT and PS are equal? PT and PS are equal. Reason, length of the tangent segments drawn from an external point are equal. So can I say angle PTS and angle PST will be equal? Isosceles triangle now. When two sides are equal, the base angles are equal. So PTS and PST. Angle PTS is equal to angle PST. So if I take the sum of all angles of the triangle, can I say it will be equal to 180 degrees there? So easily we can find out the remaining two angles first, correct? So there I can say that angle TPS plus angle PTS plus angle PST is equal to 180. This is 60 plus this is PTS. PST is equal to PTS is equal to 180. 180 goes to the other side, 60 goes to the other side, that becomes 120. So 2 times angle PTS is equal to 120. So angle PTS is equal to 120 divided by 2 and that is 60 degrees. So both the angles are 60 degrees, correct? So you can say that this is also 60, this is also 60. That means you can say that triangle PTS is an equilateral triangle, right? It is an equilateral triangle. Now since it is an equilateral triangle, can I say PT will be equal to the chord TS? That will be equal to 4 centimeter. So we got the first answer. The first answer is that the length of the chord is 4 centimeters, right? So first part is done. Length of the chord is 4 centimeters. Now let us find out the radius. Understand. So this is the radius. This is 4, correct? And if I join OP, tell me one thing. The entire angle TPS, see, angle TPS is how much? Angle TPS is 60 degrees. TPS. So this angle will be half because both of them will be equal since the two triangles will be congruent if I try to prove them. Angle TPO will be 30 degrees. So can I say angle TPO is half of 60, that is 30 degrees. So this angle is 30 degrees. How much is angle T? Angle T is 90 degrees. So how much will be angle O? Angle O will be 30 plus 60 is 30 plus 90 is 120. So angle O will be 60 degrees. So can I say triangle TOP? Triangle TOP is 30, 60, 90 triangle, correct? So you know how to apply trigonometry, isn't it? So we can say that side opposite to 30 degrees is half of hypotenuse, and then side opposite to 60 degree is root 3 by 2 times hypotenuse. So if I take side opposite to 60 degrees, side opposite to 60 degrees is TP is root 3 by 2 times hypotenuse OP, correct? But TP is 4, so 4 will be equal to root 3 by 2 into OP. So that gives you 8 by root 3, right? So OP will be equal to 8 by root 3. Now that is your hypotenuse. So now can you find out TO, that is the radius? See, there are multiple ways of doing it. If you want to do this by trigonometry, you can do that, because you can take cos 30 as adjacent upon hypotenuse, you can do that. You can take sin 60. Sin 60 is equal to opposite by hypotenuse. Or if you know this result, that side opposite to 60 degrees is root 3 by 2 times hypotenuse, you can do that as well. So you got OP now. Now can I say OP square is equal to TP square plus OT square, and that is your Pythagoras theorem. So this is by Pythagoras theorem. So OP square, that is 8 by root 3 the whole square, is equal to TP square, that is 4 square, correct, plus OT square. So this becomes 64 by 3 is equal to 16 plus OT square. So what will be OT square? OT square will be equal to 64 by 3 minus 16. 16 3s are 48. 64 minus 48 is 16, that is 16 by 3. So OT will be equal to under root 16 by 3, that is 4 by root 3. By root 3, correct? Alright, let's continue further. So again, two concentric circles. We have solved a similar question based on concentric circles. We are supposed to find out the length of the chord of the larger circle which touches the smaller circle. Very similar. In fact, same type of question was asked previously. So if we have two circles, the larger circle, the smaller circle, center of the smaller circle, there is a chord. This is the chord of the larger circle that touches the smaller circle. So suppose this is A, this is B, this is O. Now radius of the larger circle. So OA is the radius of the larger circle, correct? So what is given? OA is given. How much? Larger circle, so that will be 4. So can I say OA is equal to 4 centimeter given? And then if this is C, OC is also given. OC is equal to 3 centimeter given. We are supposed to find out the length of the chord of the larger circle. That means we need to find out AB, isn't it? I can say AB equal to question mark. Now can I say OC is perpendicular to AB? Because tangent is perpendicular to radius. So can I say angle C is 90 degrees? I can say that, isn't it? So can I say OA square is equal to OC square plus AC square? See, this OA is 4, correct? And this OC is 3. So we can say that OA square is equal to OC square plus AC square. So that is 4 square is equal to 3 square plus AC square. 4 square is how much? 4 square is 16. 3 square is 9 plus AC square. So if I take 9 on the other side, I get AC square is equal to 16 minus 9, that is 7. So I get AC is equal to root 7, correct? And that is in centimeters, of course. So once I get the value of AC as root 7, we know that in a circle, perpendicular drawn from the center of the circle to the chord bisects the chord. Write down the complete reason. So can I say AB will be double of AC? So AB will be equal to 2 times AC. What is the reason? Perpendicular drawn from the center of the circle to the chord bisects the chord. So that is 2 times root 7. That is 2 root 7 centimeters. Yes, and that is your final answer. That is the length of the chord of the larger circle is 2 root 7 centimeters. Clear? So let's have a look at a new question now. It says in the figure, a triangle ABC is given with angle B as 90 degrees, correct? So taking AB as diameter, a circle has been drawn intersecting AC at point P. So clearly you can see point P is here. We are supposed to prove that the tangent drawn at point P bisects BC. Tangent drawn at point P bisects BC. So what are we supposed to prove? So here we are supposed to prove that PQ bisects BC. That is, we are supposed to prove that BQ and QC are equal. That is, BQ is equal to QC. This is what we are supposed to prove, right? Firstly, let us construct PB, right? So what is our construction? Our construction is join PB. Now if you see, you're going to get few angles here. Let us name them. This angle A as 1, this B as 2, this is say 3, and here we have 4, here we have 5. So we have 5 angles in total. Now tell me one thing, the entire angle B is 90 degrees. So can I say angle 1 plus angle B plus angle 3 is 90, but B is 180. Sum of all angles of the triangle is 180, but angle B is 90. So angle 1 plus 90 plus 3 is 180. 90 goes to the other side. Angle 1 plus angle 3 is 180 minus 90, and that gives me 90. So as of now, I have some result, and that result is angle 1 plus angle 3 is 90 degrees. Now observe, here can we say that the measure of angle 4 plus angle 5 is 90 degrees. Angle 4 plus angle 5 is 90 degrees because tangent is perpendicular to the radius, isn't it? So what is the result that we have? We have 1 plus 3 is 90, we have 4 plus 5 is 90. But tell me one thing, can I say that angle 4 is equal to angle 1? Because if you see, when you have a tangent and a chord, that is equal to the angle subtended here. So angle 4 is equal to angle 1, correct? So in this case, if I have angle 4 is equal to angle 1, please understand, if I have angle 4 is equal to angle 1, can I write down here angle 1 plus angle 5 is equal to 90? See, 1 plus 5 is 90, here 1 plus 3 is 90. Now understand, if I have 1 plus 5 as 90 and if I have 1 plus 3 as 90, RHS is same. So can I say 1 plus 5 is equal to 1 plus 3? 1 gets cancelled and we get angle 5 is equal to angle 3. But where is angle 5 and angle 3 located? Let us see that. Angle 5 is here, angle 3 is here. So can I say this angle 5 is equal to this angle 3? Once I get the two angles equal, can I say now PQ is equal to QC? Can I say now PQ is equal to QC? Because this is of converse of isosceles triangle theorem. If the base angles are equal, the sides opposite to them are also equal. Since PQ is equal to QC, now one more thing we know, that point Q lies in the exterior. So can I say this QP and BQ are equal? Can I say BQ is equal to QP? So see, QP is equal to QC and QP is equal to BQ. So therefore, from these two results, from above results, can I say BQ is equal to QC? That is, we can say PQ bisects BC, and we have proved it. So let's have a look at a new question now. Two tangents TP and TQ are drawn to a circle with center O, and then in this case you are supposed to prove that angle PTQ is a double of angle OPQ. This is what we are supposed to prove. See, this is very simple. In such type of questions, what you do is, you can consider, suppose this angle over here as say angle X, and this angle over here is Y. So can I say we are indirectly supposed to prove, that Y is equal to double of X, correct? Now, can I say in triangle PTQ, PT and TQ are equal? Can I say PT is equal to TQ? Because length of the tangent segments drawn from an external point are equal, correct? So here, can I say that the two base angles will be equal? That is, angle TPQ will be equal to angle TQP. If I take them as Z and Z, these two angles as Z. So in this case, can I say that Y plus Z is equal to 180 degrees? Isn't it? So from here, can I say Y plus 2Z is 180? So can I say Y is equal to 180 minus 2Z? So can I say Y will be equal to, if I take 2 common, I get 90 minus Z, correct? So what do I get? I get Y is equal to 2 times 90 minus z. Now understand, can I say OP is perpendicular to PT? OP is perpendicular to PT because tangent is perpendicular to the radius at the point of contact. This we already know. So OP is perpendicular to PT, that means tangent is perpendicular to radius. So angle TPO will be equal to 90 degrees. But can I say angle TPO, this entire angle is a combination of two angles, x and z. So here I can say that x plus z is equal to 90 degrees. So can I say if I shift z to the other side, x will be equal to 90 minus z. Now what if I put 90 minus z as x? If I put x over here, I will get y is equal to 2 times x. And that is what exactly we were supposed to prove. Y is equal to 2x. Y is nothing but angle TPQ is equal to angle OPQ, but double of it, right? That is 2 times angle OPQ, and we have proved it. I hope this question is clear to you. Let's move on to a new question. It says, in the given figure, a circle is inscribed in a quadrilateral ABCD in which angle B is 90 degrees. If AD is 17 centimeter, so this entire AD, that is 17 centimeter, AB is 20 centimeters, and then DS is 3. So this small section, this is 3 centimeter, this one. Then find the radius of the circle. Okay, we are supposed to find out the radius. But firstly, let us try to understand what is given to us. So we are already given a quadrilateral in which 3 values are given. The value of AB is given. The value of AB is 20. The value of AD is also given. That is nothing but 17. Firstly, can I say DS and DR are equal? Can I say DS is equal to DR? Because there is point D, and from point D there are tangents drawn. So length of the tangent segments drawn from the external point are equal. So can I say DR will also be equal to 3 centimeter? So if DR is 3, can I find out AR? Can I say AR will be equal to entire AD minus DR? So can I say AD is 17 minus 3, that is 14. So AR is 14 centimeter. Now AR and AQ, if you see the circle and if you see from A's point of view, AR and AQ, both of them will be equal. We know that AR is equal to AQ. Same reason again. Length of the tangent segments drawn from an external point are equal. So can I say AQ will be equal to 14? I hope this is clear. Now see what's happening. We got this as 14. We got this as 14. Now entire is 20. So how much will be BQ? Can I say BQ will be AB minus AQ? How much is AB? AB is already 20. How much is AQ? AQ is 14. So 20 minus 14 is 6 centimeter. That is your BQ. Now once you get BQ, your job is done, because I'm not writing down the further part but giving you an explanation for this. Can I say angle Q is 90? Yes, it is 90 because tangent is perpendicular to the radius at the point of contact. Can I say angle P is 90? Yes, it is 90. Tangent is perpendicular to the radius at the point of contact. 3 angles are 90. Can I say the fourth angle is 90? Yes, because remaining angle of the quadrilateral. So this becomes a rectangle. So this becomes a rectangle. But now in this rectangle, can I say OP and OQ are adjacent sides of the rectangle which are equal? So whenever the adjacent sides are equal, it becomes a square. So basically OPBQ is a square. So can I say this is 6, this will be 6, this will be 6, this will be 6, and we can say that OB will be same as the radius. So the radius is going to be QB is going to be 6 centimeter. So I hope you have understood this question. Easy question, nothing much. We have solved a similar question based on it where that part becomes a square. But you have to justify why it is a square. Don't write down directly it is a square. Okay. Now we have a long case study question. So let me read out the question for you. The discus throw is an event in which an athlete attempts to throw a discus. The athlete spins anti-clockwise around 1.5 times through a circle and then releases the throw. When released, the discus travels along the tangent to the circular spin orbit, and this is how it looks. So after throwing, this is the tangent, this is the circle, which is the disc. In the given figure, AB is one such tangent to the circle of radius 75 centimeter, where O is the center of the circle. So this is more important for us, right? AB is the tangent and OA is the radius, which is 75 centimeter. And then angle ABO is 30 degrees given, and PQ is parallel to OA is also given. You can see that PQ is parallel to OA. Firstly, we are supposed to find out the length of AB. We are supposed to find out the length of AB. Correct? This is the question. Okay, then we are supposed to find out the length of OB, then AP or PQ. So let's try to look at the figure and let's try to find out the length of AB. Now to find out the length of AB is easy, but before that, what I would do is I would find out the length of OB. That is much better and easier. Now if I see in triangle OAB, I have angle A as 90 degrees. Why? Because tangent is perpendicular to radius, correct? And this is 90, this is 30. So for 30 degrees, if I look at the bigger triangle, this is 30 degrees, this is the opposite side, and this is the hypotenuse. So can we apply sine theta? We know that sine theta is opposite by hypotenuse. So sine 30 will be equal to opposite. Opposite is OA. Hypotenuse is OB. So can I say 1 by 2 is equal to OA, which is 75, by OB. So can I say OB will be double of 75, that is 2 times 75, and OB is going to be 150, correct? So the length of OB over here is going to be 150. Is it given in centimeters? Yes, it is given in centimeters. So 150 centimeters. Now we got OB. Now we have OA. But what about AB? AB is also easy to find because the first question says find the length of AB. Now looking from 30 degrees point of view, this is 30, this is opposite, or you can say this is perpendicular by base. That's your choice. You call it perpendicular by base, you call it opposite by adjacent, same thing. So can I say tan 30 will be equal to OA by AB. tan 30 is 1 by root 3 is equal to OA. OA is 75. AB as it is. So can I say AB will be equal to 75 root 3. So we got AB 75 root 3 centimeter. On the next slide we already have OB, which is 150 centimeter. Let's tackle the third question. It says find the length of AP. Now we are supposed to find out the length of AP, right? So in this, what do we have as of now? As of now, we have the entire length, that is the length of OB, which is 150. Then we have the entire length of AB, which is 75 root 3. Correct? Now firstly, can we find out or prove the two triangles similar here? Let's try to prove the two triangles similar. So if I try to prove the two triangles similar, that is triangle BQP and triangle BOA. Angle B is common. And the two lines are parallel, right? QP is parallel to OA. So can I say these two angles are going to be equal? Angle OPB, angle OAP. Angle OPB, angle OAB, they are called as corresponding angles. Write down the complete statement, corresponding angles. Now the two triangles are similar. That is triangle BQP is similar. BQP similar to triangle BOA. BOA. You know that once the two triangles are similar, their corresponding sides are in proportion. So can I say BQ, first two letters, BQ by BO, BQ by BO will be equal to QP by OA. That will be further equal to, we'll have BP by AB, right? Now put the values. BQ. BQ is how much? We don't know. So BQ by BO. BO is 150. So BQ by 150, correct, is equal to QP. QP we don't know. QP by 75 and then BP, which is nothing but this part. AB. AB is how much? Now if you see very carefully, so what do we have? We have BQ by 150, we have QP by 75 and we have BP by 75 root 3. Now see, there is a slight change here. This point Q is on the circle. This point Q is on the circle and it is like this. Okay. Now tell me one thing. If I talk about BQ, Q is on the circle now. OQ is the radius. So can I say this part and this part will be equal? So OQ will be 75 and the remaining part will also be 75. So can I write down BQ as 75? So let me write this as 75. And then once you have this as 75, you can cancel this, right? You get 1 by 2 is equal to BP by 75 root 3. Now 75 root 3 goes in the numerator. So we can say BP is equal to 75 root 3 by 2. Correct. Now that is the value of this part BP. So what will be AP? AP will be entire 75 root 3 minus 75 root 3 by 2. I can also take this as 37.5 root 3, this part, because 75 divided by 2 is 37. So what will be AP? AP will be AB minus PB. AP will be equal to entire AB minus PB. That is equal to 75 root 3 minus 37.5 root 3. And the final answer is nothing but 37.5 root 3. 37.5 root 3. If you want, you can put the value of root 3 as 1.73. If you want to keep this as your final answer, you can do that. Now there's an assertion and reasoning question. So let's try to understand this question first. It says, the assertion statement says, the tangents drawn at the endpoints of a diameter of a circle are parallel. This is the first statement. The second statement is, diameter of a circle is the longest chord. Okay. So option A says, both assertion and reason are true, and reason R is the correct explanation of assertion A. That is the first one. Second says, both assertion A and reason R are true, and reason R is not the correct explanation of assertion A. That is second. Third says, assertion is true, but reason is false. That is the third one. And fourth one says, assertion is false, but reason is true. So these are the four statements. And firstly, let's forget about the options. Let's focus on assertion and reason. So what is given? The tangents drawn at the end points of a diameter of a circle are parallel. Is that true? Let us see. If I have a circle and suppose this is the diameter, let me draw two tangents. This is tangent 1. This is tangent 2. Now we are supposed to show that the two diameters, if this is D1 and this is D2, we are supposed to show that the two diameters are parallel to each other. Are they parallel? Let us see. See, since this is a diameter, can I say half is radius, half is radius? Radius is perpendicular to tangent. So this is 90 degrees, okay. This is 90 degrees, okay. We know that because even if I take this as A and B and this as O, OA is the radius, correct? And OB is also the radius, and these two are the tangents. Let's not take it D1 and D2. If you want, you can take it, doesn't matter. It should be called as T1, T2. Diameter is only one. AB is the diameter, that is D1. Okay, anyways. So this is 90, this is 90. Are they parallel? Now see, we have studied that 90 plus 90 is going to give me 180 degrees. So we know that if there are two lines and there is a transversal, and if the interior angles over here are supplementary, interior angles are supplementary, then the lines are parallel. So yes, this is a true statement. Definitely yes, whenever we have a circle and we have two tangents drawn at the endpoints of the diameter, these two tangents are always parallel. True, this is definitely true. Second statement, diameter of the circle is the longest chord. Is it true? Now see, this is the chord, you draw other chords. Can I say this is going to be the longest chord? You are studying this since grade 6th, right? So yes, this is also true. So this is true. This is also true. But tell me one thing. Is the given reason the right reason for this assertion? Is there any connection between both of them? There is no connection, right? So can I say here that both assertion and reason, both are true, but reason R is not the correct explanation of the assertion. This reason is not the correct explanation for assertion. Although assertion is true, although reason is true, this reason is not the correct explanation for the assertion. So option B is correct. Easy? Okay. Now this is a 3-mark question. Very interesting question. Very easy also. It says, in the given figure, AB is the diameter of the circle. So AB is the diameter with center O. and there are some tangents AQ, BP, PQ. AQ, correct, at point A, BP at point B, and PQ at some point, say, can we take it as C? Okay, let's take it as C. Now, the question says, prove that angle POQ, this angle over here, is 90 degrees. That is what we are supposed to prove. Okay, we have taken a point C over here. Let us do one construction, and that construction is join OC. So what is my construction? What is my construction part? You need to join OC. Once you join OC, you get two triangles, right? Upper part, triangle QAO, triangle QCO. So can I say in triangle QAO and triangle QCO, there are two triangles. Can I say QA is equal to QC? Yes. Because length of the tangents drawn from the external point are equal. Then can I say OA is equal to OC? Yes. Because they are radii of same circle. And can I say there is a common side here? Yes, which is OQ. So I can write down OQ is equal to OQ. See, the reason for all of them are different. The first reason is length of the tangents drawn from external point are equal. Second is OA and OC are the radius. So the two triangles are congruent, right? Triangle QAO is congruent to triangle QCO. This is because of side test of similarity, right? Now, since the two triangles are congruent by side test, can I say angle AOQ is equal to angle COQ? Angle AOQ is equal to angle COQ, and both of them, they are equal to x, right? So let me take them as x, because corresponding parts of congruent triangles. Now if I take these two triangles, triangle BOP and triangle COP, triangle BOP and triangle COP, can I say they are congruent? Yes, because see, BO is equal to CO, radii of the same circle. BP is equal to PC, length of the tangent segments drawn from the external point are equal. PO is equal to PO, common side. So can I say angle, okay, so reason for this is SSS, that is side. Can I say angle BOP is equal to angle COP? Angle BOP is equal to angle COP. Let me take that as Y. So this is Y. We have a point C. This is X. This is X. This is Y. This is Y. Correct? Now it is very simple, right? We know that AB is the diameter. So this is a straight line and here is O. So what is the measure of this angle? 180 degrees. So can I say this angle x plus y will be 180? I can say now x plus y is equal to 180. So 2x plus 2y is equal to 180. Can I take 2 common? Yes. So x plus y is equal to 180. If I divide by 2, can I say x plus y is 90. So if you see this part, x plus y, this is 90. So can I say POQ is 90 degrees? So angle POQ is equal to 90 degrees. Hence proved. We have proved that angle POQ is 90 degrees. Very simple. See, in between we got x plus y, right? If I add x and y, I'm going to get POQ. So this is how you prove this. Very simple. Okay, let's have a look at a new question now. There is a figure given. It's a 3 marker And the question says, a circle with center O and radius 8 centimeter. So the radius of the circle is 8 centimeter. So basically you can say this part OP is 8, you can also say OR is 8, this is 8, this is 8, anyways. PQRS are the points of contacts. AD is perpendicular to DC. AD is perpendicular to DC, that means this angle is 90 degrees. And BS, where is BS? BS is 24. This is 24. We are supposed to find out the length of DC. We are supposed to find out the length of DC. This is question mark. Okay. Now let's try to understand this. So what is given to us as of now? There are some values given to us. BC is also given as 30. If you notice very carefully, this BC is 30, correct? BS is 24, radius is 8. So all these values are already given to us. Okay. Now let's try to understand one thing. If I join this, can I say angle P will be 90, angle Q will be 90? Can I say angle P is 90, angle Q is 90? Because tangent is perpendicular to radius. So remaining angle O will also be 90, correct? Remaining angle O will also be 90. So this becomes a rectangle, and we know that once it becomes a rectangle and if the adjacent sides are equal, can I say OP is equal to OQ? OP is equal to OQ because both of them are radii. So can I say that is a square OPDQ? Quadrilateral OPDQ is a square. So since it is a square, what is the radius given? The radius is given 8 centimeters. So if this is 8, can I say this is 8? Can I say this is 8? Can I say this is 8? Right? So all of them are 8 centimeter each. So now I got the value of dq. Basically dq is 8. Now all I need is the value of qc because I need the value of dc. So understand, here can I say BS and BR will be equal. BS will be equal to BR. What is the reason? The reason remains the same, length of the tangent segment drawn from an external point are equal. So BR will be 24. So if this part BR is 24, entire part is 30, can I find out CR? Can I say CR is equal to BC minus BR? So what will be CR? CR will be equal to BR is 30 minus BC is 30, BR is 24. So can I say CR will be equal to 6? So this CR over here is 6. Now can I say CR is equal to CQ? Can I say CR will be equal to CQ? CR and CQ are equal and both of them are 6 centimeter or 6 units because length of the tangents drawn from an external point are equal. Now this is 8 and this is 6. Can I find out DC? What will be DC? DC will be equal to DQ plus QC. I hope you have got the answer. That is 8 plus 6 and 8 plus 6 is 14. So I can say DC is 14, correct? And 14 is the final answer. So very easy. Firstly, we found out DQ. You can get it from here that R, because it is a square, radius is equal to DQ and DQ is 8. And once you get DQ, and once you get CQ, you can add DQ and CQ to get DC, that is 8 plus 6, 14. Perfect. Let's continue. Now let us see a new question. It says, a backyard is in the shape of a triangle ABC with right angle at B. AB is 7 meter, BC is 15 meter. A circular pit was dug inside it such that it touches the walls AC, BC and AB at PQR respectively, such that AP is equal to X. Basically, this is given AP as X. If you see the figure, you don't have to get confused here. Just see the figure. AB is 7, BC is 15. If you're not able to visualize, no worries. The triangle and the circle is there. Just look at the figure and see what are we supposed to find out. So there are 4 questions here. If you see, we're supposed to find out length of AR with respect to X. Then we are supposed to write down the type of quadrilateral BQOR. Where is O? O is here. Correct? Then we are supposed to find out the length of PC in terms of X, and also later find out the value of X is what they are saying. Okay. So they are saying find X and hence find the radius of the circle. So this is a pretty clear and a simple figure. Let's focus on the first part, that is finding out AR. Okay. So here what is given? It is already given that AP is X, right? It is already given that AP is equal to X. Now can I say AP is equal to AR? Correct? See, if AP is X, in the question it was given AP is X, what will be AR? AP is equal to AR. What is the reason? Length of the tangent drawn from the external point are equal. Therefore, can I say AR is also equal to X? And we are done with the first part. Because that's how it is. The entire AB is 7 and AP is equal to AR. So AR will be X. Okay. What type of quadrilateral is BQOR? So BQ, this is OR. Correct? Now understand. What is angle B given? Angle B is already given as 90 degrees because it is a right angle triangle. This is given. Then, can I say angle Q is 90? Because tangent is perpendicular to radius. Can I say angle R is 90? Tangent is perpendicular to radius. The reason for both of them is tangent is perpendicular to radius. So remaining angle, that is angle ROQ, will be equal to 90 degrees because this is the remaining angle of a quadrilateral. Sum of all angles of the quadrilateral is 360 degrees. So you can just write down this is the remaining angle. So as of now it is a rectangle. That is, we can say now quadrilateral BQOR is rectangle. If it is a rectangle, can I say RO is equal to BQ? Opposite sides of the rectangle are equal. Can I say RB is equal to OQ? Opposite sides of the rectangle are equal. But can I say, but it's already given that RO is equal to OQ because they are radii. Now see how to connect. It is already given that RO is equal to OQ. It is already given that RO is equal to OQ. But what is RO equal to? RO is equal to BQ. So just write down BQ here. And what is OQ equal to? OQ is equal to RB or BR. So can I say here all the four sides are equal? All four sides are equal. And here all four angles are 90 degrees. So we know that when such a condition is satisfied, the quadrilateral, a square. So what is the answer to this? The answer is that this quadrilateral is a square. I hope this is clear. Simple. Let's continue further. Now we are supposed to find out the length of PC in terms of x. Okay. So length of PC is over here. What is given to us? It is given that this is 7, this is 15, this is 7. It is already given that AP is x. Correct? Can I find out AC? We know that angle ABC is 90 degrees. So can I say AC square is equal to AB square plus BC square? So can I say AC square is equal to 7 square plus BC square, that is 15 square. So that is equal to 49 plus 225. Correct? 7 square is 49, 15 square is 225. And if you add this, you are going to get 274. So can I say AC square is 274. So AC will be equal to under root 274. Correct? Because if you see the figure, AB is 7 given, BC is 15 given. By Pythagoras theorem, we can easily find out AC. And obviously ABC is a right angle triangle given, so definitely we have the leverage to use the concept of Pythagoras theorem. Okay. So what happens over here is, after you get this, can I just split it 274? If I divide by 2, I get 137. Correct? There is nothing much that you can do. So once you have under root 274, what will be PC? PC will be equal to AC minus X. See, AC minus X means AP, entire AC minus AP. So PC will be equal to under root 274 minus X meters, right? This is in meters. So that's it. That is your final answer. Correct? The second part is, hence find X and also find out the radius of the circle. Now see, this is X. This entire part, if you remember, is under root 274. Correct? Now this part is X. This is also X. We are supposed to find out the radius of the circle. Let us see what all information do we have. Okay. So as of now, we don't have that information. All we have is, this is 7, this is 15, this is X. So definitely this part over here is under root 274 minus X. X, entire part is 7. So this remaining part is how much? 7 minus X. So this part is also going to be 7 minus X, right? Because BR will be equal to BQ. BR and BQ will be equal. That will be equal to 7 minus X. Now understand, entire AC was under root 274. Correct? PC was under root 274 minus X. So can I say PC and CQ are equal? So CQ will be equal to under root 274 minus x. So CP is equal to CQ is equal to under root 274 minus x, right? How much is BC? Can I say BC will be equal to BQ plus QC? But BC is 15, so 15 will be equal to BQ. BQ is 7 minus x plus QC. QC is under root 274 minus x, right? So this becomes 15 minus 7 is 8. 8 is equal to under root 274 minus 2x. So if I take minus 2x here, so 2x plus 8 is equal to under root 274. Now if I square on both the sides, this becomes 4x square, 2 into a into b, 2 to the 4, 4 8 the plus 32x, correct? And this is equal to 274. So if you divide this by 2, what are you further going to get? You are going to get 2x square plus 16x minus 137 is equal to 0. What you need to do is, you can use the quadratic formula to find out the value of x. That is minus b plus or minus root of b square minus 4ac by 2a. And you get the value of x as 4.28. This is the approximate value. Of course, you cannot split the middle term over here. And once you get x as 4.28, now can I find out BQ? Now can I find out BQ? BQ will be 7 minus 4.28, and that is nothing but 3.72. And 3.72 will be nothing but the radius, right? So radius will be equal to 3.72. That's meters. And the value of x they told us to find out is already over here, that is 4.28. Perfect. So that's it. I hope you have understood this chapter and enjoyed the chapter alongside me. Now keep learning with top scholars. We'll see you again in the next session. Thank you.